All right, today we're talking about adding integers. In terms of adding integers, there are actually three types of integers. There's only three types of integers anyway, but those three types of integers are positives, negatives, and zero. In terms of adding integers, what we need to understand is that positives tend to work together. They love other positives. Negatives also love other negatives. Positives and negatives, however, don't work together, and we'll talk about what happens when positives and negatives mix. But for now, let's focus on just the positives. Only when adding integers, and today again we're only talking about adding integers, remember that positives work together. If positives were walking down the street, they saw the positives, they'd be all excited to see each other, they'd high five, and be like, this is awesome, let's go to Zynga and get some frozen yogurt. They'd be hanging out, it'd be a great time. The three positives met up with four positives, three positives and four positives make seven positives. They don't fight, they don't change, there's not less of them, they don't turn into negatives, they just add together. What is 5 negatives plus 10 more negatives? Sorry, 5 positives plus 10 positives, 15 positives. 8 positives met up with 7 positives that made 15 positives, and then 15 positives and 14 positives combined to make 29 positives. Again, positives are good friends, they love each other. Here's a picture that sort of shows that. These two positives are very happy hanging out with each other. This positive says, you're my best friend. And he says, I love you, man. And they're good friends, they love each other, and they have a good time, they party, and everything is awesome. Positives love other positives. On top of that, negatives love other negatives. If negatives are walking to, hanging out at the bowling alley, and they're like, oh my God, my other negative friends. We're all good friends. And they're hanging out, two negatives met up with 3 negatives. There'd be 5 of them, and they would all go. They would join a basketball team and those 5 negatives, and they would dominate the league with their 5 negatives. Here's an example with numbers. If two negatives saw 3 negatives, and they added together, they become 5 negatives. They don't change to positive. They don't change. It's just 2 added to 3 makes 5. Showing you in a picture, 2 negatives gets added to 3 negatives. Nothing happens except now there are just 5 negatives. That's what happens. If 4 negatives met up with 7 negatives, they would combine to make 11 negatives. If 8 negatives met up with 50 negatives, that would be 58 negatives. If negative 1 met up with negative 4, that'd be negative 5, plus, negative 3. You guys see why I put the parentheses on the second one, right?
Yeah.
Just so we can separate the number. It's not a subtraction sign. I just don't want you to be confused. 5 negatives plus 3 negatives is 8 negatives. Here's another picture to illustrate my point. Got a birthday party. And this guy says, happy birthday! And this one says, thanks, we're having so much fun together. Because they like each other, because they're both negatives. Negatives work together. What 0 does is nothing. 0 does nothing. It's called the additive identity, but 0 does nothing. We know this. What is 5 added to nothing? 5. What is 31 positives added to nothing? 31 positives. What is 7 negatives added to nothing? 7 negatives. What is 0 added to negative 90? Negative 90. Again, this is called the additive identity. It's one of the properties. It's an additive identity. Your identity is who you are. Who you are does not change. Here's another picture. There's 0. He's very sad. You know why he's sad? I feel like I just don't have any effect on people. It's because he doesn't. Now that's great. We now know that positives work together. We know that negatives work together. But when positives and negatives meet up, they do not like each other. Positives and negatives do not like each other. Positives and negatives are going to fight. If a positive met up with a negative, well, there'd be some sort of battle. If we had, on one side of the room, if we had 7 positives, and on the other side of the room, if we had 5 negatives, and we add them together, there's going to be a fight. Some numbers are going to have to die. Some of you are going down. The thing is, though, these 5 negatives and 7 positives someone's going to come out a victor. We're going to find out who comes out the victor and by how many. We're going to see what actually happens. When the 5 negatives and the 7 positives meet up, there's going to be a fight. They fight, and who wins the fight? Well, it's always whoever has more. There's more positives than negatives, so these positives are going to end up winning. They end up winning by 2, because these 5 negatives didn't go down without a fight. They took out some of those positives. Those 5 negatives left 2 remaining. And that's how we'll decide who's going to win. In this situation, we have 5 positives and 3 negatives. And this is the sort of thing I want you to think about in your head. Who's going to win, positives or negatives? You just say it.
Positive.
Positives are going to win because there's more of them. How many do they win by?
2.
Do they fight or work together?
Fight.
Who wins, negatives or positives?
Positive.
Positives win by
2.
Oh, you guys know this is the same question, right?
Yeah.
Needed property of addition. Do they work together or against each other?
Against each
Who
other.
wins, negatives or positives?
Negative.
Negatives by
3.
3. Who wins, positives or negatives?
Positive.
Positives win by
7.
And they work against each other. Who wins, positives?
Negative.
Negatives win by
2.
So if you look, again, this is sort of like, so student block 1 said, isn't that sort of like subtraction? Yeah, it's sort of like subtraction because you're seeing how many are left over. Here's one last picture. They're ready to fight. Ready? It's going to get really cheesy. Ready? I'm going to enjoy canceling you out. And he says, maybe, but we both know what really matters is who has more numbers. Yeah. All right, so let's do these very quickly. And this is the narrative. This is the thing that you should be saying in your head every time you do this. Do these numbers work together or against each other? Together. 3 positives plus 8 positives is 11 positives. 0 does nothing. This is called the additive identity.
Negative 19.
Do these numbers work together or against each other?
Together.
What's 4 negatives and 3 negatives?
7.
7 negatives. This is a common question students get wrong. They often say the answer is 0. It is not 0. Do they work together or against each other? Together. What's 7 negatives and then 7 more negatives?
14.
This is the same question 4 and 5. This part is negative 14. Just do it one part at a time. Now it's negative 14 plus 0, another additive identity, negative 14. Again, add these together. These work together, negative 3 plus negative 4. They again work together, that's negative 7. Do these numbers work together or against each other?
Against.
Finally, a fight. Who wins, positives or negatives?
Positive.
Positives by
4.
And that's how you would do these problems. So we can continue finding the sum by actually doing our good guy, bad guy type. Do they work together? Do they fight? Are they friends? We can continue actually finding the sum. We're simplifying the expression. But I want to talk about modeling. Oftentimes when students think about modeling the expression, they're concerned because they think it's totally different. They think when they do this stuff, they think, oh, this is adding and subtracting. This is add and actually find the answer. And here's modeling. And they're totally different, but they're not. Modeling will get us to the answer. So when you see modeling and adding is actually the same thing. They both get us the answer, just another way of doing it. Which is more efficient? Modeling, or just doing the work? Doing the work is much more efficient, but modeling will give us a deeper understanding. So we're going to model this expression. We're going to model how to do this negative 5 plus 10 using what are called integer chips. Now one of the important things to do is to make a key. You should write this down. If you don't make a key, we'll never know what we're doing. Do your keys have to be circles? No, they could be like squares or rectangles. Usually we do the filled in one as negative. You could do like circles and have a negative and a positive. I don't care how you do it as long as you have some sort of key. If you don't have the key, then we don't know what we're doing. When we start our modeling, you always start with the first number that's given, in this case negative 5. Negative 5 is my first number, that's the number I'm going to use, that's the number that's going to get me started. How do I draw -5 using integer chips? Well, it's easy. You just draw 5 negatives. 1. Well, actually, I can do it even more efficiently. I can do this. You guys don't have to do this. I need 5 of these negatives. 1, 2, 3, 4, 5. I now have 5 negatives. It's that easy. Whatever the first one is, that's what you draw. If they ask for instead to model, and it was 2 plus a -3, you would start with, again, you have your key, and I'll just draw it real quick. That's a +1, that's a -1, and they wanted me to draw 2 plus -3. I'd start with my first number, which is 2, so I would draw 2 positives. The next step, once we have that, is just doing the next part. This question would start with 5 negatives, add 10 positives, and let me add 10 positives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's it. Don't put a plus sign, don't put an equal sign, that's it. Do not put a plus sign, do not put an equal sign, that's it. If you'd like to, you can circle the things that pair up, because guess what? You know what 1 negative and 1 positive is?
0.
0. 0, 0, 0, and 0. What am I left with?
5.
+5. Which, by the way, just like I mentioned here, the answer and modeling are the same thing. It's the same thing. Do they work together or against each other? Who wins, negatives or positives?
Positives.
Positives by,
5.
which is the same thing. So if you don't end up with the same number, you did something wrong. If someone were to ask me to model, let's say this one, I know before I even start this modeling down here, these two numbers fight, the negatives win by 1. So when I'm done, I should have 1 negative. Let's find out what happens. All right, I have 2 positives. When we add to this 3 negatives, that's 1 negative, that's 2 negatives, that's 3 negatives. This cancels, what am I left with?
-1.
Oh, wow, that is so weird that it was the same answer. You need to know that it's the same thing and use that to help you when you model. This one says to model. In terms of modeling this, if you take a look and we cheat ahead of time, what's 3 negatives and 4 negatives? 7 negatives. So I know in the end I should have 7 negatives. We can actually sort of, this is actually almost easier, but some students get tricked by this. We'll start with 3 negatives, 1, 2, 3. I'll add to that 4 negatives. And the temptation is to cancel them out. But does a negative cancel a negative?
No.
No. So that's why it's just 7 negatives, which is what we have. That's modeling with number chips. Now we also have to model on a number line. If we're asked to model on a number line, we can take the same problem, say for example -5 plus 10, we can also model this on a number line. This is where students start to get lost. But if you remember that we know the answer, then it won't be a problem. We can still get to the spot we need to be. You see this first number, this highlighted number? This is still the number we're going to start at. So when we get to our number line, I'm going to make a number line here. That's the number we're going to start at. If you want, put it right in the middle. Yes, put -5 in the middle. Once you have that written down, we're going to add 10 to that. If we add 10, what direction are we going to go in? The left or to the right? If we add 10, what direction are we going to go to? You can just call out.
Right.
To the right. So I'm going to go to the right. I'm going to make some marks. 5, that puts me 0. 1, 2, 3, 4, 5. That puts me at 5. Let's extend this. 1, 2, 5. Let's put it to 10. You want to see what students do incorrectly? They start at -5 and they say, oh, plus 10. Let me go to 10. This is wrong. Don't do that. What was my answer? We already did this problem. What was the answer? 5. +5. Where should I end up at? 5. Here's how it works. I start at -5 and I add 10. So let me add 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Weird, what number did I end up at? 5. It is not a coincidence. You're adding 10, you're going to end up at the answer. Not where you want to end up, not 10 away, not 10 into the number 10. You'll move that amount of times. Let me do another example for you, and I'll do this one. If we're drawing, modeling this in the number line, what number do I start at? What number do I start at? You just call out 2. The number that's highlighted, the first number to start at 2, you can put that right in the middle. Now I want to move 3 times. The question is, do I do 3 to the right or 3 to the left? If I'm giving you negatives, what direction would it give me negatives? Left, so we're going to go to the left. 1, 2, 3 times, I end up at -1. But there's a problem with what I just drew. What's the problem with what I just drew? For example, I want to hide it for a second. Where did I start and where did I finish? Do you have any idea? Based on my picture, do you have any idea? So what do you think would it be important to do, since I don't know where to start and where to finish? What do you think would be important to do on my picture? Well, I don't need numbers because you should be able to tell what numbers they are. So it's not that I need more numbers. We'll address that in a second, yeah. How would I do that? How did I do that in the picture? So I do an arrow. If I start at 2 and I finish at 1, you could draw an arrow. Do I need to have numbers on all of the spots? For example, if I point to this one right here, do you know what number I'm pointing at? Yeah, it's 4, right? It's 1 less than 5, but I didn't write the number 4. How'd you know it was 4? You guys can figure that out. That's not the part I'm worried about. You guys need to actually have arrows, finish, and end. Let's do one more example. How about you guys do this example? Model this on a number line. We know that 4 is the first number. So since 4 is the first number, that's the number I'll start in the middle. I also know that this number indicates how many times I'm going to move. So I'm going to move 6 times. The question is, do I move 6 right or 6 left? Well, I know I'm going to move 6 to the left because of the negative. But if I wasn't sure, I can do 1, 2, 3, 4, 5, 6 this way, and 1, 2, 3, 4, 5, 6 this way. But really, I know which way I'm going to go for 2 reasons. 1, I know that, again, this negative moves me left. But 2, I know what the answer is. I know I'm going to end up at, this is 0. I know I'm going to end up at -2 because I know what the answer is. It's -2. If you don't end up at -2, you didn't do it correctly. Let's do it anyway. Start at 4, do a nice little dot at 4, and I'm going to move 6 times. 1, 2, 3, 4, 5, 6. -2.